Welcome to the third video of the series Business Statistics. In the last video, we discussed some terminologies and concepts regarding descriptive statistics. And in today's video, we are going to see how to calculate or find those values or those concepts using those concepts using Excel and Minitab. So, first of all, let us consider this particular set of data. Here you can see that the data is about food consumption, and the food consumption under various categories are given here for a given time period, and in every each date the day code, day of the week is mentioned, and the sales of these categories has been reported, and then therefore there is a total sales, and also it has mentioned the maximum temperature of the day and the total wastes also. So anyhow, we are not going to discuss every variable in this data. Only we will take only few parts of the data and try to implement the calculations. But first of all, let us try to see which type of data belongs to which categories. So earlier in the discussion portion, part 1 of the module 1, we have given you 4 categories of data: categorical, ordinal, interval, and ratio. So I will discuss one or two from here. Rest all you will yourself check using this given check sheet which data belongs to what category. And so first of all, see, time and dates are given. So generally time and date comes under the interval category because in some way they can be measured. They are ordered, of course they are ordered. They are equidistant. That means the gap between two time units and two dates can always be equidistant, and but they don't have a meaningful zero. See? So in most cases they are considered interval data. However, you can also consider as ordinal data because the measurement of time and date is kind of dicey, and you cannot actually say that we measure it. So maybe you keep a cross sign under the measurement portion of this check sheet and only say that it can be ordered. So from that point of view, it is an ordinal data. Okay, so then the sales of these categories, you can check this. They can be measured. Of course, they can be measured. They can be ordered. They are equidistant, and they also have a meaningful zero. So therefore, this category of data will be considered as ratio data. Another thing I want to mention here is for ratio data, the quick checkpoint is you should always try to see if basic mathematical operation of the data has some real meaning. That means if you consider addition, subtraction, then multiplication and division, try to see if those things really produce any meaningful values. For example, sales. Here we are considering sales. So can we add sales? Yes. Can we subtract sales? Yes. Multiplication? Yes. Division? Yes. So therefore sales is a ratio data. But in case of date or time, addition does not give you anything meaningful. Subtraction, yes, possible. It gives the time gap or time gap or the date gap. Multiplication, again no meaning. Division, again no meaning. So it cannot be a ratio data. So in this way, please study all these variables by yourself and determine in which category they belong. So that's all about the data classification portion. Now we will study the descriptive statistics measure. here. And for that, first of all, you need to delete this observation. You see here, the observation is blank, not applicable is written in each column. So we don't want to see this in the data. So we will remove this data and then study. So let me remove this for you. So we will find the descriptive statistics measures using the descriptive statistic report in Excel or in Minitab only for sales. And you can use the same method and procedure for all other variables here. Or we should actually do it for the ratio type of data, and there is no point in calculating descriptive statistic measure for date and time or day code or day of the week, because date and time are ordinal data or interval data, and day of week and day code, these are categorical data. Also note that this particular point I was discussing in the last video, although the day code are numbers 1 2 3 4 5, 1 is for Monday, 2 is for Tuesday, and so on, are they ratio data? Even though they are numbers, in this case they are not ratio data. Why? Because simple checkpoint I told you before this, that for ratio data, just check if these numbers can be added, subtracted, multiplied, or divided to get some meaningful output. So if you add the day codes of 2 days, will it give you something meaningful? For example, I add 4 and 5 for Thursday and Friday, so that is 9. But what is 9? You don't have any meaning for that. So this cannot be a ratio data even when numbers are here. So just by looking at the data and seeing that they are numbers, you cannot classify them as ratio data. So this is the one important point to remember. So now let us find take out the descriptive statistics report for sales here. So you just go to data analysis. Here you will find descriptive statistics. Just click here, and for the input range, you select the entire data sales and click here on levels in the first row, because we are selecting using the headers also. That means the sales text is also selected here. So we have to mention that the first row is level only. So once this is done, select any blank region of the worksheet, or even if you select this option, it will be populated in a new worksheet. So but then what do we need here? We need summary statistics, confidence level of mean. You can take it out, but I am not covering it in under descriptive statistics, so you may ignore this right now. Then these things also I don't want to include right now. So click on OK. So here is the report that you will get from the descriptive statistic tool pack. So what do we see here? We are reported that the mean is 148.22 for this sales variable. The standard error is given, median is given, mode is not given. Why mode is not given? You see, every sales value are unique here. So you cannot say that some sales value has a higher frequency than the other. Everyone has equal frequency. It means they have occurred just only one time in the entire data set. And so, therefore, there is no data point for which the frequency is higher than the other. So they have not reported mode, not applicable. Mode is not applicable for this type of data. And then standard deviation is calculated, variance is calculated, and then kurtosis and skewness, they are also calculated. So I will describe these things in a moment, how to interpret kurtosis and skewness coefficients. Then range is given, maximum and minimum is given, Sum and count is also given. So what is the range? Range is nothing but the max minus min. So if you subtract this 61 from 240, you will get 178. And this report is generated using Excel. And now we'll generate the same or similar kind of report using Minitab. So in Minitab, I am using Minitab 19.1 version. And if you have any lower or higher version, the entries may be little bit different, but essentially they will be similar. So in Minitab 19, the data portion comes in the bottom part of the page, and it is, to my belief, it is little bit difficult because the reports will be generated in this portion of the window, and then the data is at the bottom portion of the window. So in most of the cases you will only see partial data. You just have to scroll down to enter to get the data or the graph to see it entirely, or you have to minimize this data portion. So both of these actions are not very suitable in my opinion. In the earlier version of the Minitab, this problem was not there. So anyway, so I have copied the data in this mm, portion of the window, that is the table part where the actual data will be posted. And you see, when we have a categorical data, then the column names will be different. So C1, C3, C5, C6, they are all ratio types of data according to Minitab. And so only C1, C3, C5, C6, like this, they have shown. Whenever there is a categorical data, then the column numbers, they will categorize as, for date, they will put D, and for any kind of categorical data, they will put T. Okay, doesn't matter. So you go to basic statistic, display descriptive statistics. So this is for sales. In C20 we have the sales data, so we'll select that, and that will come in variable section. By variable means, if you want to subdivide the data, that means you have sales, suppose you want to bifurcate the descriptive statistic measures according to some categorical variable, say day of week. So in that case, it has to be used, otherwise don't use. So click on statistics and select whatever is needed. So I need these things. I need variance, coefficient of variation. So remember, these things were, some of these things are not present in the Excel report. For example, coefficient of variation you will not get in Excel directly. You may calculate it indirectly. Then I need range. Then I need interquartile range. I may not need mode here because mode is not applicable for this type of data. Then I will need skewness, kurtosis, and that's all I need. So I'll click OK and then again on OK. So we'll get this type of reports. So see here, mean, standard error of mean, standard deviation, variance, coefficient of variation, minimum, quartile 1, median, quartile 3, maximum, range, interquartile range, skewness, and kurtosis. All these things are given. So I have not discussed this IQR, Q1, Q3, and percentile. I will discuss these things in detail after some time. So keep it in mind that these are important parameters also. Also in Excel, you are not getting these things. So Q1, Q3, and IQR, these are essential elements, and is more important when we will construct box plot. And also I need to describe skewness and kurtosis. But before that, let us check how to get the descriptive statistics using by variable. So earlier in this table we are getting the descriptive statistics values for sales, irrespective of any category, for total sales for all the days given here. But suppose I want to see these measures day wise, so I will enter day of week in by variables. So if I do that, then it will populate like this. So again, same measures as given here, only now it has bifurcated the measures according to the days of week, as you can see here. So this may be also important in some contexts. So Excel will not give you this type of functionality. So Minitab is very handy. You can use SPSS also for this type of functions, but Minitab is much more easier. Okay. So now we will directly come to the graph section, where we will discuss some of these graphs and their purposes. So first off, we will start with histogram. So in histogram, we will normally select this with fit histograms, and then there are others also. I will discuss this in a moment. So click on OK. Suppose we are developing the histogram for sales. So we'll enter sales here. I am just double clicking on this. So if you double click on this, it will automatically be entered in this part to develop the histogram. So this is the histogram for sales. So see, the reports are actually obtained selecting this. So first off, we were getting the descriptive statistics for sales, then category wise sales descriptive statistics, then now histogram. So if you select these things, the reports will be found. Otherwise, you have to scroll. So this is the histogram for sales. So now if you just double click on this, you will get the you can edit the graph from here. So you don't have to edit anything. Only thing is, you may want to edit the x-axis. So instead of automatic x-axis, you may position your tick in a more closed kind of beans. So for example, they have calculated the frequencies. For example, from 40 to 80, only this much is there. These are the frequencies. The bars are the frequencies. So from 40 to 80, only one value is there. From 80, 80 to 90, I think uh, the frequency is 3, and some so on. So if you want, you can change these values. For example, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240. You have to keep a space between them, and then if you click on OK, see, these are now more closely spaced. So you can alter this to get the histogram in a more beautiful manner. So this is how the histogram will be developed. So now I want to discuss this little detail. Some people have confusion about histogram and Pareto chart. So some say that they are same, but actually they are not the same. What are the differences? I will discuss now. So if you are encountered with a chart, then if you are confused whether it is a histogram or it is a Pareto chart, then you should remember these things. So for that, histogram is also already here, as we have developed in this chart. Let us develop a Pareto chart. So for that, you have to go to statistics, quality tools, and Pareto chart. And you have to use any categorical variable here. So let us consider day of week. This is the only best categorical variable present in our data. Normally, Pareto chart is made for um, getting the frequencies of defects or problems or issues, but we don't have this type of data here. We are just trying to show you the difference between Pareto and histogram, and therefore using day of week as a categorical variable in order to make a Pareto, which is a stupid thing. For day of week, never a Pareto will be made, but I don't have anything else to do here. I don't have any other meaningful categorical variable for which I can develop a Pareto. So I am just using this example to elaborate the difference between the Pareto and histogram. So if you click on OK, so this will be your Pareto chart. So this is Pareto and this is histogram. So can you figure out the difference? If you just only see the bars here, you'll be confused. So let us make it objectively clear why Pareto is not histogram and why histogram is not Pareto. So I will explain this in the slide. So let us come to the slide. So here's the thing. This is my Pareto and this is my histogram. So what are the difference? There are primarily two differences. First one, in case of Pareto, the x-axis, the x-axis is always categorical, and what else? The categories are ordered as per the descending frequencies. What does that mean? So see, the Tuesday frequency should be greater than or equal to the, sorry, the Thursday frequency should be greater than or equal to the Tuesday frequency. The Tuesday frequency should be greater than or equal to the Wednesday frequency, and so on. So that means always you will get a Pareto in this format. The first bar will be greater than the second bar, then the third bar, then the fourth bar, and so on. So the categories here, categories in the x-axis are ordered in that manner, and the x-axis is always categorical data. So some categories are here. So either it is a defect, so defect or problems or issues, those are in the x-axis, and in the which order? In the order of their frequencies, in a descending order. Okay, so then what is histogram? In histogram, you see the x-axis. X-axis are the beans. Now, what are the beans? Beans means they are ranges 40 to 50, 50 to 60. So 40 to 50 is one bin, then 50 to 60 another bin, then 60 to 70 another bin. These are examples only, and you cannot change the order. Orders are as per the bin itself. The bins themselves. Means what? That means 40 to only 50 to 60 can come only after 40 to 50. Then 60 to 70 will come only after 50 to 60. So the order, this order cannot be changed. So the x-axis will start from the lowest value and end in the highest value, irrespective of the frequency. Whatever be the frequency. Here, the order was based on the frequency itself. Here, order was based on the x-axis value itself. So these are the two differences. So as you can see here, the Pareto will be always in this format. The first bar will be the highest frequency bar, the second will be less than that, the third will be less than that, and so on. But in case of histogram, this may or may not happen. For histogram, the first bar may be like this, second may be like this, The third may be like this, fourth may be like this, fifth may be like this. So we don't have any control over this. Only thing we control here is the order of the bins. The first bin, second bin, third bin should be in this order. So B2 should be greater than B1, B3 should be greater than B2, and so on. So these are the two differences between Pareto and histogram. So now that we have seen the histogram, let us come to other graphs. We have dot plots here. The next tool is dot plot. So if you go to dot plot and enter cells here, you get this type of report. I don't think it is very different from what is given by histogram. Almost the same thing, only in the frequencies are counted in terms of number of dots like this. Here in histogram, it was a continuous bar, and in dot plot, they have counted the frequencies using dots only. That's the main difference. Then in graph, probability plots. This is one important thing. So we have to discuss this more in our inferential statistics part. So if you get this probability plot here, normally this is checked for to test whether the data is following a normal distribution. So you see probability plot for sales, normality. So it is checking the normality of the data. If the data is around this central straight line and within these two bounds, then we can say that the data is following normal distribution. We will discuss this more in our inferential statistics part. So for now, you just remember that if a data is given to you and you want to check whether it follows a normal distribution closely, then you need to go to the probability plot and plot this and check whether the points are close to this central straight line and within these two bounds. If the points are like this, as it is seen in this diagram, then the data is most probably following a normal distribution. Okay, that was your probability plot. Next is box plot. But before discussing box plot, I need to discuss quartile and percentile using small nuggets of information. Then only we can understand the box plot. So let us come to the slide once again.